Sanibonani Dumelang, hello and welcome to Tenfold Live. I am your host, Pia Matebula, and today, like every other day, we bring you nothing but the best content to help you ace all of those exams. But before we get into the nitty-gritties of things, we just want to send a big shout out to our sponsors, Liberty. Thank you for making all of this possible. Now, guys, remember, we are an interactive show. We engage, so we want you guys to engage with us. You can get a hold of us on all our social media platforms. We are available on our app. It's called Tenfold Education. You can download it on iOS or Play Store. You can also catch us on WhatsApp. Just send a text there, and you will get a response from us with all those questions that you have. And then you can also stream us live on YouTube. We are Mindset Learn. So do get into it. And also we have Facebook, guys. So do get into asking those questions all on those social media platforms, Facebook, WhatsApp, and our own app. So from me, I'll see you guys later. Smooth, take it over.
Right, thank you very much, buddy. A very warm welcome to all of you Tenfolders. Thank you for joining us on Tenfold Live. My name is Sibusiso, and as always, I'm very excited on another show that is proudly brought to you by Liberty to be with you and help you learn how to analyze the questions and concepts that are on analytical geometry. On today's program, we're going to give you secrets, techniques, and strategies of mastering and acing analytical geometry. It's a very simple concept, very, very exciting, but the only problem with it is that it actually opens doors to other concepts of math. So the reason why sometimes you will not get all the marks in this section is because you will forget about the fact that there's sometimes other sections that get dragged in when you're working with questions that are about analytical geometry, particularly when you get to circles. So I'm looking forward to showing you how Euclidean geometry, trigonometry, as well as algebra play a role when you're dealing with analytical geometry questions. Without any waste of time, let's go to our first question. All right, so this question reads as follows. It says in the diagram, ABCD is a quadrilateral having vertices A with coordinates 7 and 1, B with coordinates -2 and 9, and C with coordinates -3 and -4, and D with coordinates 8 and -11. M is the midpoint of BD, right? Now, it's always important, we always emphasize this, it's important for you to make sure, before you can even indulge on trying to solve the problems, make sure you read the diagram and you understand what is going on. It's very important for you to make sure that you read the love letter, because there's always a lot of very useful information that you will use to try and answer questions based on whatever is going on in the diagram. So one of the most important things that I already see that you might not have seen is the fact that M is the midpoint of the line BD. So if you expand this further to see what is going on, we can clearly see that this point is in the middle. So that means at some point, if they ask you for the coordinates of M, you'll just use the concept of the midpoint theorem. Okay, cool. So let's go and see what the questions are. The first question is asking us to calculate the gradient of AC, right? Calculate the gradient of AC. Now remember, the formula for calculating gradient is not bad. It's very simple. We all know that the gradient of any line, in this case AC, will always be the change in Y values divided by change in X. That's Y2 minus Y1 over X2 minus X1. That's how you can also write the formula, right? So I need to know what is the Y coordinate minus the other Y coordinate divided by the other X coordinate minus the other X coordinate on the other point. It depends which point you want to work with, right? If you're starting with point C, you'll have to use the Y coordinate of C minus the Y coordinate of A, the X coordinate of C minus the X coordinate of A. So it's important for you to make sure that you don't mess up the order when you're doing the subtractions. Always Y is on top and the X is at the bottom. So let's go and see what the coordinates of A and the coordinates of C are. You'll notice that the coordinates of A are 7 and 1, and then C is -3 and -4. So 7 and 1, -3 and -4. So let's put those and try and find what the solutions are. So A is 7 is to 1, and C is -3 and -4. So we can clearly see that these are the coordinates of point A and point C. 7 and 1, -3, -4, right? 7 and 1, -3 and -4. So what you're going to do here is just try and figure out what the differences are going to be. So I'm going to put Y value here, -4 minus 1 over -3 minus 7, okay? You'll notice that -4 minus 1 will just leave us with the value -5 divided by Negative 3 minus 7 is actually negative 10. So eventually, you end up with a solution that says the gradient of the line AC is just equal to 1/2. Very simple and straight to the point. Okay, cool. The follow-up question here says we need to determine the equation of AC in the form y equals mx plus c. Now, what's the take home from this question? Well, finding the equation of a straight line. Every time when we ask you to find the equation of the line in the form y is mx plus c or in any other form, you obviously need to know what the ingredients need to be. The first thing that you need is you need a gradient of this particular line we're talking about. And then the second thing that you need is you need a point on this particular line. If you've got these two things, you can find the equation of any line, okay? Now, do I have a gradient of this line AC? We just found it from the previous question. We know the gradient is going to be 1/2. Do I have a point anywhere on this straight line? In this case, you happen to have 2 points, so you're spoiled for choice. The solution is still going to come out the same, all right? As long as you don't mess up your math, everything else will be fine. So I'll start first of all by putting y is mx plus c. I'm not putting y is mx plus c because they want it in that form, but this is actually how you will always start trying to work out the value of this thing. What is the gradient? The gradient is 1/2, all right? So we need an x value and a y value of the same point. You have to make sure that you're taking the same point when you are working with these particular questions, right? So the point I'm looking for that I said I'm going to pick is point A, and the x coordinate at A is 7, and the y coordinate at A is 1. It has to be coordinates of the same point, okay? So you've got 1 equals to 7 multiplied by 1/2, which is just going to give you 7/2 plus c. And then eventually you'll end up with a c value. When you subtract on both sides, 7/2, it will be as good as saying 2/2 minus 7/2. In case you find yourself in a position where you don't have enough resources to try and figure out what the answer is going to be, well, you can always change 1 and write it as anything divided by itself. So I just called my 1 2/2. I'm subtracting 7/2 on both sides of the equation. We end up with a c value of exactly -5 divided by 2, okay? Now then it means that the equation is going to be y is equal to 1/2 of x minus 5 divided by 2. You could have written this also as 2.5. It doesn't really make a difference. Now, just to add value on what you're currently watching, sometimes they'll ask you to write the equation in the form ax plus by plus c equals to 0. Now, you'll notice that if you're not using whatever they were asking in this particular question, but you're trying to write it in this form, it will really mean that whatever you have here has to be taken a step further. Number one, you'll notice that what they would be asking for does not have a fraction, and secondly, all your terms are on the left of the equality sign. So that means I'll firstly make sure everything goes left, okay? I will move 1/2 to the left, or maybe subtract 1/2 x on both sides. I'll end up with minus 1/2 x. I will keep my y on the right-hand side. I will add 5/2, or maybe, which is what you people call moving 5/2 to the left. It will be positive 5/2 equals to 0. So that's the first thing I will do. Move all my terms to the left, and then double everything. It doesn't matter when you're multiplying all of them by -2, or just multiplying all of them by 2. If I double the first term, I'm going to get -x. If I double y, I'll get 2y. If you double 5/2, you'll get 5 equals to 0. So this is another format that they can ask you to use when you're trying to find the equation. It doesn't mean that you'll have to start it from that format. Your equations of straight lines will always start this way, y is mx plus c. And then after finding the solution, then you can express it in the form that the examiner is asking you to actually use. Okay, moving right along, we go to the third question now. The third question is asking us to determine whether M lies on this particular line, right? Whether M lies on the point, on the straight line AC. Now let's go back and check what is going on in the diagram. So we were told that M is the midpoint of the line BD, right? But we don't know much. So what we're trying to investigate now is we just spoke about the line that passes through A and C, and that point will definitely be this one. So we're just wondering, will that point M be on that particular line, right? Now, for you to be able to do this is always very simple. You need to just take the coordinates of the point we're talking about and substitute in the equation, right, that you just found. We know the equation of AC. Just take the coordinates of M and substitute on the left and on the right hand side, which means substitute for both X and Y, and see if this point satisfies the equation. Do not transpose stuff, right? Just put wherever you see X, the X coordinate of M. Wherever you see Y, put the Y coordinate of M, and try to check, do I get the left-hand side equal to the right-hand side? If they are equal, it means that point lies on that particular equation. It doesn't have to be a straight line. It could be any equation in the world. If you want to see how whether a point satisfies that equation or whether a point lies on that particular graph. Just check if the coordinates satisfy the equation. Okay, now let's go back and check what is going on here. Number one, we're going to need to obviously find what the coordinates of M are. Now, let's choose this space to find what the coordinates of M are. We were told that M is the midpoint of the line BD. So I'm just going to calculate the midpoint coordinates, okay, which is x1 added with x2 divided by 2, y1 added with y2 over 2. This is the formula we use to try and work out the coordinates of the midpoint. Now, my x coordinate are 8 and negative 2. So you say negative 2, you add 8 on that, you divide this by 2, okay? And then for the y coordinate, you take 9, which is the first coordinate. You add negative a half, you divide that by 2. And then it gives us the m coordinates as exactly 8 minus 2, which is 6 over 2, that's 3. And then 9 minus 11 is negative 2. Over 2, which is going to give us negative 1. So the coordinates of m, according to this, are supposed to be 3 and negative 1. And I'm leaving them here. So what I'm going to do is I'm going to go back to my equation and check if these coordinates satisfy the equation which is found, which happens to be the equation of AC. All right? So remember what I said. You'll have to work out the coordinates of m first. We just found them as 3 and negative 1. Now go back to the equation. Remember the equation was saying y is a half of x minus 5 over 2. So don't transpose anything. Don't add anything on both sides. Just see when you substitute the coordinates, does this satisfy the equation? So for y, I'm going to sub negative 1. And then half is a half. For x, I'm subbing the x coordinate, which is a 3 minus 5 halves. All right? So you will see that on the left-hand side, I still have negative 1. On the right-hand side, I'm going to give 3 halves. 3 halves minus 5 halves will give you 2 halves, which are negative, and then eventually this is going to amount to negative 1. So what do you notice when you get the answer negative 1? It then comes out that the left-hand side is equal to the right-hand side. Just because the left and the right are equal, then we can conclude that therefore M does lie, right? Does lie on the line AC. It only lies if the left-hand side equals to the right-hand side. Okay, cool. Moving on to the next question. We are now asked to prove that the line BD is perpendicular to the line AC. BD is perpendicular to the line AC. All right, let's go back and check what that means. Now, you will notice that line BD is actually a diagonal. BD is a diagonal, even AC is also a diagonal. So we are being asked to prove that this angle here would be 90 degrees, right? I know the diagram doesn't look like it is, but remember, we never really ever draw diagrams to as accurate as you might want. They're not drawn to scale, basically. So for you to prove that two lines are perpendicular, what comes to your mind? If you want to prove that the line AC, okay, is perpendicular to the line BD, we have to prove that the product of their gradients gives you negative 1. So you want to prove that the gradient of AC multiplied by the gradient of BD will give you an answer of negative 1. If this happens, then that's proof enough that the lines are perpendicular, because that's what we know about perpendicular lines. The product of their gradients will always give you a negative 1. Very important. Okay, cool. So let's go and check what we're going to do here. Now, what I want you to keep in mind is the coordinates of B and the coordinates of D. It's negative 2 and 9, okay? And the other one is 8 and negative 11. Negative 2 and 9. All right, so let's go to try and find a solution here. Negative 2 and 9. B is negative 2 to 9. D is 8 and negative 11, okay? Already, we know the gradient of AC. We found it as 1 over 2 from the previous question, right? So for these things to be perpendicular, the product of the gradients has to be negative 1. Now, what I just need to figure out is what is the gradient of this particular line, right? What's the gradient of the line BD? Okay, so the formula for gradient is the gradient of BD will be changing y over changing x. So it's going to be y2 minus y1 over x2 minus x1. I'm subtracting a negative there, right? Y minus y divided by x, okay, minus x. You'll see there, I'm just taking 11, I'm minusing a 9. I also have to take 8 and minus a 2. The order has to be the same. I'm doing D minus B, D minus B. Very important. So on the numerator, I'm getting a negative 20. On the denominator, I'm getting a value of positive 10. And my answer here comes out as negative 2. Now, once I have this, I'm now going to check, does the product really give me negative 1? So the product of BD and the gradient of AC, the product of the gradients, is just negative 2 multiplied by a half. And the answer comes out as negative 1. Just because the product is negative 1, therefore we can conclude that BD is indeed perpendicular to AC. We did prove that they are actually perpendicular to each other. If they were asking us to prove that they are parallel, we then try to prove that the gradients are equal because parallel lines have equal gradients. A beautiful question that is touching a lot on the basics to help us refresh ourselves before we begin with the more complicated questions. All right, the next question says calculate theta, the inclination of BD. Another very awesome question. How do you work out the angle of inclination? Well, you have to remember what is the meaning of the angle of inclination. The angle of inclination is the angle between the x-axis and your straight line. Now, remember what you're dealing with now. We know that the x-axis and BD have the following relationship. The line we've got BD looks like this. It has D here and it has got point B there. We're asking you to find this angle theta. That's what we call the angle of inclination, the angle between the x-axis and the line of interest. Very important, okay? So how do you work out the value of that? How do you work out the value of that? You're going to have to say the gradient, okay, of BD, and you equate that to the tan of that particular angle. So in my case here, I'm going to obviously say tan theta is the answer we got, which is -2. So that means theta will be arctan -2, okay? But because of the fact that we're dealing with a negative gradient, we're going to get an angle that happens to be obtuse. I hope you guys can see what is going on here. Now, what is important is I want you to pay attention to the fact that if I get a negative angle here, this is very, very important for us to explain. I'm going to get a negative angle because the gradient is coming out negative. And the angle that I'll be finding is basically the angle that is here, this one here. Do you see here? In this little corner there. That's the gradient that I'm actually going to be calculating, all right? So very important for us to keep that in mind. It's very, very important for you to know what you're getting when you're working out an answer. So let's call the calculator and try to figure out what is arctan 2, because this is so important. I want you to understand. It's about understanding, not just the answer, but an understanding of what is going on. When you do arctan -2, you're going to get an answer that is negative. It's negative 63.43. Negative 63.43 whatever degrees, right? What is that? Where is it here in the drawing, right? When you find something like this, I want you to know that you just found an angle here. I think you guys know that from the cast diagram. When we count our angles, our 0 degree is always here, right? This is where we have our 0 degree angle. And when we count our angles, we count them anti-clockwise, right? Because 90 degrees will then be here and then and so on and so on. We all understand this story. But what if it didn't go this way? What if you went that way? You'll then be going in the negative direction because that anti-clockwise is the positive way of counting angles. Now, the fact that I ended up with an angle that is negative 63, it means I have this angle here that you will get when you're going this way, when you're going clockwise. Are you happy? But we don't want that. We want the angle on top. And I hope you can see that these angles lie on a straight line, and angles on a straight line are up to 180. So I can then rob these or cheat my way around this by just adding 180 or whatever you have from the calculator. Just add 180 there. It will help you work out what the value of the angle of inclination is going to be. So let's go back to the calculator. Whatever you have, just add 180 on that. It gives you 116.57. So 116.5, is it 57 or 56? Let's look at 116.57 degrees. Yes, it's 116.57 degrees. That's the angle of the inclination theta, which is the angle of inclination of the line BD. Okay, now they're asking us to figure out the size of CBD. Let's go and see what this CBD is in the drawing. So CBD is this angle here at the top. They want this angle here, CBD. So they want you to figure out what the value of that angle is. Now, I'm going to draw your attention to what is happening here. Allow me to delete some of the things so that we have much more clearer drawing and then we can all see what is happening here. I want you to pay attention to what we have so far. We're going to come back to these coordinates of B if we ever need them. So what we have figured out now is the value of this angle here. Okay, we know this angle here, which is 116. We know that this is 116.5 whatever. What is the angle there? 0.57 degrees, right? This is the value of the angle here. Now, if I could join here and figure out what the value of this angle is, right? There's a relationship between this angle. Let me call it beta and call the angle that you're looking for, whatever it might be. In this case, it's CBD. So when you add these two angles, right, they will always give you the angle that is outside. And this is the concept of Euclidean geometry. The sum of the interior angles in the triangle equals to the exterior angle. Since you already know this one, if I work out the value of this one, I'll be able to get the value of whatever that angle is going to be. Okay, this is a very beautiful question. So let's continue and try and figure out what the value of beta is. If I know what beta is, then I can be able to get the answer. Now, the tan of angle beta is obviously going to be equal to the gradient of the line BC, okay? So we need to know what the gradient of the line BC is going to be. So it's changing y over changing x. So that's 9 plus 4 divided by -2 plus 3, okay? That's the value of the angle of the gradient of that y2 minus y1 over x2 minus x1. So I'm ending up with an answer here of exactly 9 plus 4, which is 13, divided by 1. So I'm getting an answer of 13, which is very interesting. Okay, I'm getting a gradient of exactly 13. So if the tan of beta is equal to 13, then the angle beta, right, will be arc tan of that number 13. And then we can be able to get our angle from that, right? So arc tan, okay, where is that? Open bracket, 13. I can be able to get the answer to this. It's actually 85.60. So it's 85.60 degrees. What angle is this? That would be the angle here, 85.80 degrees. Now, if I've got this, I know that the sum of the two will actually equal to the exterior angle. This comes from Euclidean geometry. So that means in order to figure out the solution to this, what I'm simply going to do is I'm going to say, well, this is very basic. The area is very simple. We're looking for the angle. So I'm going to say angle CBD, okay? Angle CBD equals to 116.57 degrees minus 85.80 degrees. Why? Please give us reasons. Because the exterior angle equals to the sum of interior opposite angles. So sometimes if you guys don't provide these reasons, you're going to have a lot of problems. We won't give you all the marks that you deserve to get because you're not actually doing the right thing in terms of arguing what is going on here. So I need that 116.57. Okay, delete, backspace, 116.57, subtract the answer which is found here, alphabet answer. Okay, then I'm going to get an answer here of 30.97 degrees. So the answer ends up being 30.97. So 30.97 degrees would be the answer to this particular angle that you're looking for. So it's a very beautiful question that opens up doors to a very, very awesome concept, which is analytical geometry. We can now understand how to work out midpoint coordinates. We now understand how to work out unknown coordinates if you ever need to. You know how to work out the gradients and the angles of inclination. It's very exciting. Thank you for sending through the question. We're coming back with more exciting content. Don't go anywhere. We'll be right back.
Did you know that a full head of human hair is strong enough to support 12 tons? We have on average about 150,000 hairs on our head. According to research, the molecular structure of hair is such that a single strand can support about 100 grams. This means that the combined hair on the average human head would support over 12 tons, which is about the weight of 2 African elephants.
Welcome back, everybody. You are still tuned in to Tenfold Live. Yes, guys, remember, we are an interactive show, and we want to interact with you all the time. But before we get to interacting with you, we'd like to send a big shout-out to our sponsors, Liberty. Thank you so much for making all of this possible. Now, guys, let's get into the nitty-gritty of things. Now, if you guys want to win yourself or stand a chance to win yourself a sharp calculator, then you have to send through your questions. And if your question gets chosen, you can win yourself that calculator. So do connect with us on all our social media platforms. We are available on our app. It's called Tenfold Education, sorry. It's called Tenfold Education. We are also available on WhatsApp. We are also available for streaming live on YouTube. So do get to connect with us so that you can also engage. You know what I mean? Yeah, so over to you, Spoo.
Thank you, Bade. Thank you very much, and thanks to you, Tenfolders, for watching Tenfold Live. This show is proudly brought to you by Liberty. A big shout out also goes out to Liberty for sponsoring our program. We're very grateful because they're giving us the opportunity to impart knowledge and share all that we know with you as you send us the questions that you want help with. On today's program, we are working with analytical geometry, one of my favorite topics. And the next question is very exciting because it's going to help you understand the integration between analytical geometry, Euclidean geometry, and other concepts of math. So without any waste of time, let's go right into it and see what is going on. Okay, cool. So this is question 4, and it reads as follows. It says in the diagram, a circle having center at the origin passes through P with coordinates 4 and -6. PO is the diameter of the smaller circle. Okay, so PO is the diameter of the smaller circle having center M. The diameter RS of the larger circle is a tangent to the smaller circle. So it's very important for us to always make sure that we analyze the love letter, because this love letter is packed with a lot of very useful information that sometimes you don't get to see in the drawing. Remember never to make assumptions. We have to tell you things if you ever need to use them. Things such as tangent, diameter, you can't assume them. We have to tell you that they exist for you to see what is going on, right? So one of the things that stand out for me is the fact that we were told that OP is actually a diameter of the smaller circle and O is the center of the smaller circle. Okay, cool. And then the other thing we're told is that the bigger circle has a center at O, okay? And then we know for a fact that the line RS is a diameter also to that particular circle. Another important thing is that that line is a tangent to the smaller circle. So those kinds of things are very, very important pieces of information. Now, before we go anywhere, since the bigger circle, this is just to show you some of the things that I want you to have in your mind. The equation of the bigger circle is obviously going to be x squared plus y squared equals to r squared. Why? Because it has a center at the origin. If the center is at the origin, the equation of the circle always takes this form. However, the equation of the smaller circle, this one right here, will be x minus a all squared plus y minus b all squared equals to r squared. Just showing the distinction between those two circles. Why? Because it has got a center somewhere else, where the small a and the small b in the equation will just be the coordinates of this point M that you see here, depending what the coordinates are. We'll sub those here for a and b, okay? That's the distinction or the difference between these two. Okay, very important. Now, let's go and check what is going on here. The first question says you need to calculate the coordinates of M. So we want to find the coordinates of M. So M is a point that is in the middle, which is the center of the smaller circle. What we know so far is that that smaller circle is a beautiful circle. It has M at the center. It's actually at the center of the point P here and the point O, which is the origin. The coordinates of the origin are obviously 0 and 0. So what we just need to know is what are the coordinates of P. Once we know this, we can then be able to work out what the coordinates of M are going to be, since M is the midpoint of these 2 points. So M will obviously be x1 plus x2 over 2, and then the y coordinate will be y1 plus y2 divided by 2. All right, so M would be 1x coordinate is 0. We are adding that to the x coordinate at P, and then we also need to know the y coordinate at P. So the coordinates of P, according to the question, are 4 and -6. We are very lucky. We're given those, so it's going to be easy. We have 4 here, and we have -6. So it's going to be 4 here over 2, and then it's going to be 0 plus -6 all over 2. And then the answer for the coordinates of M are eventually 2 is to -3. Those are the coordinates of point M. Okay. The follow-up question here says we need to determine the equation of the larger circle. Okay, like I said, all you need to know is remember that if it's centered at the origin, it will take the form x squared plus y squared is equal to r squared. Okay. Now what you need is the length of the radius. If you don't know the length of the radius, you can then try and figure out any point that lies on that particular circle. Now, as far as the bigger circle is concerned, what do we know? We know that it passes through a point P with coordinates 4 and -6. This concept is a universal concept that works anywhere. You can sub this x and y coordinates for x and y and work out what the length of r squared is going to be, okay? So I'm going to sub 4 here where I see x, and then I'm going to sub 6 where I see y. So 4 squared, and then we've got -6 squared in brackets equals to r squared. Now that is 36 plus 16. Let's go and figure out what 4 squared plus 6 squared is going to be. So that's just the sum of 36 and 16. We're getting an answer of 52. So 52 is r squared. I don't even need to know what the radius is because the formula of the equation works with just r squared. So I'm just going to take this and sub it and say therefore the equation will be x squared added with y squared is equal to 52. Remember, we always use r squared for the equation and not r, just r squared. Okay, cool. The next one says to us we need to determine the equation of the smaller circle in the form x squared plus y squared equals to cx plus dy plus e. Now, what do we know about the smaller circle so far? Well, we know that the smaller circle has m in the middle, and the coordinates of m, we found them as 2 and -3. We also know that that circle passes through point P with coordinates 4 and -6, and we also know that it passes through the origin with coordinates 0 and 0. So because we know all this information, we can be able to find the solution without any problems. Why? We said the starting point is going to be x minus a squared. We'll be adding that with y minus b squared equals to r squared, okay? So x is x minus your a value, which is the coordinate of the center. Our x value is 2 there, squared. We add that with y minus of a minus is going to give you a positive 3 squared equals to r squared. I don't know what the length of the radius is. You can obviously work out what the length of the radius is going to be. Now, like I said, I'm repeating the same thing we just said now. If you know the point that the line is passing through, you can just take those coordinates there, right? And substitute them where you see x, and then substitute that one where you see y. It doesn't have to be that point. It can also be this point P that you see here at the bottom. I can take this x value and put it for x, and I can take this y value and substitute it for y. I just like 0 and 0 because it's easier to work with those ones. So I'm going to have 0 minus 2 squared, and I'm going to have 0 added with 3 squared is equal to r squared. Now that's a 9 and a 4. I'm getting an answer of 13 as my r squared. Now check this. They don't want the equation in the form x minus 2 squared added with y plus 3 squared equals to 30. This is another form of the equation. It gives you the center and the length of the radius. They want us to expand this and get it in that form, right? So I need to break these brackets and get them in correct form. So this is the binomial squared, right? So x minus 2 squared, you obviously square the first term. You're going to get x squared, okay? And then after squaring the first term, you're going to have to square the last term, which is going to give you a plus 4. Square x and square -2. Now the middle term is this times this twice. So you multiply the two numbers and then you double the result. So 2 and x will give you 2 times 2 will give you -4x, okay? Now let's do the same thing for y plus 3 squared. Square the first term, you get y squared. Square the last one, right? You're going to get a 9. But then the middle term is the product of these two guys, double. So 3 and y is 6. If you double that result, you're going to get 6y equals to 13. Now I promise you the sum of 9 and 4. This 9 is positive. This 4 is positive. They will give you 13. That 13 will cancel out with this 13 on the right hand side. So if I'm just trying to express it in the form that the examiner is asking for, I'll get x squared, and I'm going to need to add that to y squared. They said x squared plus y squared. The next term they want is the x term, and then the y term, and then whatever constant we're going to have with 0 on the right hand side. So I'm going to have minus 4x here. I'm going to have plus 6y here equals to 0. I don't have a constant in this case, so that is eventually what I'm ending up with as the equation of the smaller circle. Okay, moving right along. The next question is asking us to determine the equation of Rs in the form y is mx plus c. Now, once more, we're asking for equation. When we're asking for equation, you need two ingredients. What are those? You need the gradient of the line, and what else do you need? You need a point that the line is passing through. So those are the ingredients of finding the equation of any straight line. And they're asking it in a form y is mx plus c. So what line are they talking about? They're talking about the line RS. Now, if you go back to the drawing and you try to locate the line RS that they're talking about, the line RS is the line that passes through the origin. So the point we're going to take is the coordinates 0 and 0, and then we can obviously figure out what the answer is going to be. Now, something very interesting here is going to come up. We don't have the gradient of that line RS, right? We don't have it, okay? But what we know is from this drawing, the line OM is the radius, okay, of the smaller circle, and it will be perpendicular to the tangent of the smaller circle, because in the context of the smaller circle, RS is the tangent and OM is the radius. And what do we know from Euclidean geometry? We know the theorem that says if you've got a circle, the tangent of that circle will always be perpendicular to the radius of that particular circle. So that's the idea I'm going to engage here, okay? That's what I'm going to use. So I'm going to firstly argue that these guys are perpendicular to each other, because then that will allow me to use the product of this one and that one is equals to -1. It's a very, very powerful technique that works all the time. So what do we know? We know the coordinates here are 2 and -3. That means I can work out the gradient of the radius, okay? So I'm going to first of all start by saying the gradient of OM, the radius, times the gradient of RS, the tangent, equals to -1. Someone is asking why? Well, because that's the mathematical symbol for because, by the way, because the tangent is perpendicular to the radius. You may forfeit marks for not making this argument, because it's not everybody who knows that these two are perpendicular to each other, right? Very, very important. Okay, so what do we know? We can find the gradient of OM. So let's find the gradient of OM. The gradient of OM equals to change in y over change in x. So it's actually -3 minus 0 divided by 2 minus 0. We'll be ending up with an answer of exactly -3 over 2. If the gradient of OM is -3 over 2, then the conclusion is therefore the gradient of RS will be the same thing upside down, right? Will be the same thing. It's going to be the same thing, what you're looking at, but it's going to be positive. Whatever you have here, just flip it upside down. If you flip it upside down, you're going to get +2 over 3. It changes sign, and then it also changes order. I promise you, when you multiply this number with that number, you're going to get this -1 that we're arguing here. So I've got my gradient is 2 over 3x. So I can then go back there and try to write the equation of this particular line that they're asking me about, okay, RS. So it's a very beautiful question they're asking. Very, very simple stuff. We know it's passing through 0 and 0. We know the gradient is positive 2 over 3, okay? Therefore, the equation is going to be y is mx plus c, okay? I'm just going to write it in full because this show goes beyond the questions that you're asking. We always want to open your mind to all possibilities that you may have. The gradient is 2 over 3 and x. Remember, c is the y-intercept of the line. So this is where the graph cuts the straight line cuts your Cartesian plane. So since c is a straight line, at the point where the graph cuts the y-axis, and this particular line we're talking about passes through the origin, it will mean that c is equal to 0. So that means this is the equation of the line RS that asking us about in the form y is mx plus c. Remember, c is the y-intercept, and our straight line happens to cut the y-axis at 0. Okay, now the next question asks us to determine the length of the chord NR, where n is the reflection of r in the y-axis. Okay, what are the key words in this particular question? First of all, we're asking you to find the length, okay? Very important. Secondly, we are telling you that this point n is a reflection of r in the y-axis, okay? That means the y-axis would be the mirror in this case, okay? So I'm going to go back, find r, put the y-axis as the mirror, and then try to find what the coordinates of n are going to be. Very important. So we're going to go back here and try and figure out what is going on here. We've got r here, okay? They say r is a point on the big circle, but the important thing is that the point they're asking us, which is n, will lie somewhere here. Not this side. I'm actually wrong, because that will be making x-axis the mirror. We don't want the x-axis to be the mirror. We want the mirror to be the y-axis. So we want it to go this way. So that means we need a point here. This is where n is going to be, because my mirror is going to be the y-axis. The question says it's the reflection by the y-axis. So first of all, I need to know what the coordinates of r are. If I've got these, I can just be able to find what the coordinates of n are going to be, because obviously the y coordinate is going to be the same, but the x coordinate will depend on how far r is from the origin. If this is the mirror, the distance from the mirror to r will be equivalent to the distance from the mirror to n as well, okay? So the problem is about working out the coordinates of r. Now, what do we know so far? Number one, in order to work out the coordinates of r, what's happening at r? At r, the circle intersects with the line. So this is the point of intersection of two graphs. The circle and the line meet each other here. So I need to find the equations of both those and solve them simultaneously. Once you solve them simultaneously, you get the coordinates of what r is going to be, okay? Very important. So let's go back and see what we have so far. We know that the equation of the circle, okay, we know the equation of the circle is x squared plus y squared equals to 52. We did find it, right? We're looking for the coordinates of the reflection. So first of all, at r, the circle and the straight line are equal, right? Okay, so the equation of the circle is x squared plus y squared equals to 52, right? That is my first equation. And the line which is found now, which is rs, has the equation y equals to positive 2 over 3x. So that is going to be our equation 2. So I'm now going to sub this equation. Wherever I see y, I'm going to drop this guy here, which is exactly there. I'll just put y as 2 over 3x and then solve and find what the x coordinate is going to be. So we've got x squared plus my y is 2/3 of x squared. The answer is supposed to be 52. When you're squaring this, remember you're squaring everything. You're squaring the fraction, you're also squaring the x. Most of you forget what is going on here. So that's going to be x squared, add that to 4, and then it's going to be a 9, and that's going to be x squared equals to 52. I don't know about you and how you feel about these things. I'm one person who hates working with fractions. So I'm going to just multiply all my terms by 9, because I don't like this 4 over 9 that you see here. So you multiply x squared by 9, it's going to be 9x squared. You multiply 4 over 9 by 9, it's going to just give you 4x squared. And then you multiply 52 by 9. The product of 52 and 9 is a very simple question. It's going to give us the answer 468. So it's going to be 468. So I'm going to have 468 as the answer to that product. You add these two, you're getting 13x squared is 468, okay? And then if you divide that by 13, you're getting 36. So my x squared is coming out as 36. Take out the square root on both sides. Your x is going to come out as plus or minus 6. Remember, you're getting two answers all the time when you're working the values of this. Okay, so depending on what we are dealing with, you can clearly see that according to the diagram, the x coordinate of r has to be 6. It has to be 6 because of the positioning of r. It's on the right-hand side of the y-axis. Once my r is that, I'm just going to substitute x here to get the value of y, right? Y is going to be 2 over 3 multiplied by 6, and then 3 is just going to give us a value of 4. Okay, therefore y is going to be 4. So our y value is going to be 4 there. Very important. Okay, so let's go back and write them. We know that x is going to be 6, and then we know that y is going to be 4 because 6 times 2 is 12. 12 divided by 3 is going to give you an answer of exactly 4. So the coordinates of r are coming out as 6 and 4. What does that mean about the coordinates of the missing point? So you're just moving back. You're moving back here, okay? So the coordinates here, the y coordinate is going to be the same. So it's also going to be 4. But the x coordinate is going to be -6. Why -6? Because the distance as you travel from the mirror to point R is actually 6 units. So you also have to travel 6 units moving from the mirror to the point of reflection. You also need to move 6 units. And that's why it becomes -6. Very important, okay? Now, we're asking for the length of the chord. That means the whole thing, NR, is just going to be 12 units long. That's the answer to what these people are asking us to actually figure out here. Beautiful, beautiful question indeed. So let's go back and see. Determine the length of the chord, therefore the chord, NR, right? Then we can conclude that therefore NR is going to be equal to 12 units in total, right? Very powerful. The last question here is asking us for the following. They say the circle with the center at M is reflected. This is transformation, very powerful concept of transformation. The circle with center M is reflected about the x-axis. Now the mirror is now the x-axis. That means you're now reflecting about the x-axis instead of reflecting about the y-axis. Very important for us to keep that in mind. So the x-axis is going to be the line of reflection. We're reflecting what? The entire circle, okay? Let's have a very simple diagram of what the small circle looks like. So far, we know that the small circle looks like, I'm going to draw a very terrible circle. It's fine. Please forgive me. My artistic skills are not that impressive. Okay, cool. So this is the line of reflection. Where is the x-axis? The x-axis looks like this, right? I'm only drawing the x-axis and the small circle because we're interested in the x-axis being the mirror. So if this is the mirror, then the reflection of this thing is going to be like that. It's going to reflect from here to there, and it's going to look like this graph. So this piece here, think about it, this small piece here will now be here, okay? And this big piece here will now be here, right? Very powerful. Now we know that here is the origin, which is point O, very powerful. And now we just need to know what this is, because they're asking us to calculate the length of the common chord of these two circles. The chord will obviously be the distance from one circumference to the other circumference. So clearly, the common chord they're asking for is this blue line here, okay? So they want that. We were not given anything here, so we're going to introduce our own variable. You can call it anything, right? I want to call that, but they said obviously the center of this one is K, right? The center of the smaller circle is M. We want the length of the common chord. There's nothing that was given here, so I'm going to introduce any, you can even call it T. Let's call it T. Let's say this point is T. Now, T is actually on the circumference of both circles. I need to know what the coordinates of T are. Obviously, one of the coordinates is 0 because it's along the x-axis. So I just need to know what is the x coordinate. Now I'm going to take the equation of the small circle, which we have already found. We found that the equation of the small circle is x squared minus 4x plus y squared plus 6y equals to 0 from our previous calculations. I'm subbing grade 12s. This is not news. I'm just doing substitution and solving an equation. I'm plugging 0 here. And I'm also plugging the 0 there, wherever I see y. If you plug 0 those two places, I promise you, you're going to get this as a 0, and you're also going to get this as a 0. They will just disappear. You end up with just x squared minus 4x, which you can then factorize x in it. You're going to then get x into x minus 4 equals 0. So x is 0, or x equals 4. It makes sense that the t coordinates are going to simply be a 0 and an x value of 4. Now that means since the origin is at 0 and 0, the distance OT will just be 4 units. The length of the common chord OT, therefore common chord, okay, equals 4 units. Very powerful. That will be the answer to this particular question. You can clearly see that once you know how to do reflections, you can tell that from the origin moving to this point here, which is where my T is, you're just traveling 4 units to the right-hand side of this particular origin. Very powerful question, absolutely exciting indeed. I hope it has helped you to iron out a couple of misconceptions that you might be having on this, and then you understand how to reflect stuff by either the x-axis or the y-axis, depending on where you go. We're coming back with our last question. Don't go anywhere, we'll be right back.
No one ever asks why we do the weird things we do. Like, why once is never enough? Or doing 2 trips is just one too many. Why do we, before we use these, or say 5 when we mean 20? Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there? Cross our fingers, touch wood, and struggle to hide our true feelings. At Liberty, we want to know all the weird and wonderful things that make us human, because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Did you know that the temperature of a lightning bolt can be 5 times hotter than the surface of the sun? A bolt of lightning can reach temperatures of about 30,000 degrees Celsius, while the surface of the sun is only about 6,000 degrees Celsius on average. This means that a bolt of lightning is over 5 times hotter. although admittedly, that heat only lasts for fractions of a second.
Welcome back to Tenfold Live to all you mindsetters. Remember, guys, our show is interactive, so we need to interact with you all the time. So do engage with us. Send us all your questions. But before you send those questions, we just want to send a big shout out once more to our sponsors, Liberty. Thank you for making all of this possible. None of this would have been possible without Liberty. So thank you so much. Guys, remember I said we are an engaging show, a very interactive show. So we want you guys to send all your questions. You can send your questions on our app. It's called Tenfold Education. You can download it on iOS or you can download it on the Play Store. You know, just send through the app, engage with our tutor function. Do a lot. There's a lot to check out there, so do check it out. It's Tenfold Education. You can also send through your WhatsApp. Just send a hi to the number on the screen, and then we'll also respond to all those questions that you send there. And then you can also send through. You can also stream us live on YouTube. We are Mindset Learn on YouTube. And yes, guys, we also have Facebook, so you can also send through all those questions on Facebook. We are Mindset TV. Send through those questions, and we will respond to those questions. Remember, guys, you can also stand a chance to win a sharp calculator if you send through your question, or if your question gets chosen, rather. So if your question is chosen, you can win yourself a sharp calculator. So over to you, Spoo.
Thank you, Badelabi. Thank you very much. And thanks to you, Tenfolders, for being with us. An absolutely exciting edition of Tenfold Live, proudly brought to you with lots of love by Liberty. Thank you guys for being with us, and thank you for calling as many people to come and join us on this very awesome edition of Tenfold Live, where we are looking at analytical geometry. Let's go to our next question without any further waste of time. All right, so this question reads as follows. It says in a diagram, the equation of the circle with center F is x minus 3 squared plus y minus 1 squared equals r squared. S with coordinates 6 and 5 is a point on the circle with center F. Another circle with center G with coordinates M and N, right? In the fourth quadrant touches the circle with center F at H such that FH to HG is 1:2. Right? The point J lies in the first quadrant such that HJ is a common tangent to both these circles. JK is a tangent to the larger circle at point K. Very powerful. Keywords, always important for you to make sure that you analyze the given statement. If you don't analyze the given statement, there's a lot of information that you'll miss, particularly in analytical geometry, Euclidean geometry, in fact, anyway, but more important on these geometry concepts. It's very important for you to start with the love letter before you start looking at the questions. Okay, cool. So let's go to the first question and see what we can actually do on this one as fast as we can. First question says, write down the coordinates of F. Okay, F. What is F? F is the center of the circle. What's the equation of that particular circle? We know it was given to us as x minus 3 squared, y minus 1 squared equals to whatever the radius is. Just know that the 3 and the 1 will form the coordinates of the center. So F is going to be 3:1 very quickly. So the coordinates of F are just simply going to be 3:1. Okay, cool. Next question says, write down the length of HG. Length of HG, where's HG? H is this point here, and we are looking for G, which is the center of this one. Now, you don't know any coordinates on G. You don't know coordinates, so you have nothing here. So you can't use the distance formula. But there's a beautiful relationship that was given to us here about the relationship between FH and HG. So if you want HG, I'm just going to figure out what the length of this is going to be, right? But that FH can't be worked out since we don't know the coordinates of H. So I'm going to work out the length of Fs. If I know what the length of Fs is, since Fs is the radius, Fh is the radius, I'll know what Fh is, and then I'll be able to find what Hg is, because according to this ratio of 1:2, Hg is always double whatever Fh is. They have the ratio 1:2. So my Fs, okay, is the square root of x2 minus x1. So it's actually 6 minus 3, because F is 3. Obviously, we know the coordinates of F are 3 and 1, okay? Squared, add that with the y coordinate, which is 5 minus 1 squared. So I'm going to have 9 here, and that's actually 5 minus 1 is 4 squared. So 9 plus 16 that will give you 25. The square root of 25 gives us the length of 5 units, right? So if Fs is 5, then it means Fh is also equals to 5 because they are both a radius and a radius, the plural of which reads radii. Therefore, Hg will be double that, right? It's going to be double what you're looking at, so it's going to be 10, since we were given the ratio that Fh to Hg is 1:2. So that's the length of Hg. Very powerful. Next question is asking us to give a reason why JH and JK are equal. Why would those two lines be equal to each other? Why is the line from J to H equal to the distance from the line J up to K? Well, it's a radius and a radius. What do we know about those two? We know that the radii drawn from the same, not radius and radius, but a tangent and a tangent. So the reason why those would be equal is because they are tangents drawn from the same points. Tans from the same point are actually equal to each other, okay? The last question is asking us to find the distance of Fj if Jk is 20. Find Fj, we're looking for Fj, okay? So how are we going to find Fj? Well, Fj is quite easy. Fj is a distance from F to J. And if I'm looking for that, I just need to know that this is actually a right angle triangle. We already know that this one is 5 units. If Jk is 20, it means this one is also going to be 20. So you apply the theorem of Pythagoras, the distance Fj is going to be the square root of 5 squared plus 20 squared. And then you can be able to get the answer from that. Because you've got 20 and you've got 5, you'll be able to get the answer as the answer for the length of Hj. Very powerful question indeed. Unfortunately, we ran out of time. Thank you very much for joining us on Tenfold Live. We'll meet again next time. A big shout out goes out to Liberty, and a big shout out to you and our production team for being part of this program. Until next time, thank you for being with us. We'll see you again next time. Bye-bye.